So we're still adding and subtracting rational expressions, but now we need to look at what happens when we don't already have a common denominator. So the answer to that is that we have to create a common denominator if there isn't already one there. So here I have a denominator of x minus 2. This one's x squared minus 4. Those aren't the same thing, so I don't have a common denominator. In this case, I want to factor any of the denominators that factor, so I'm only worried about the bottom of the fraction. So this one, since it is a difference of perfect squares, would factor into x plus 2 and x minus 2. So this one has both. This one just has an x minus 2. So it's missing the x plus 2. So I need to put an x plus 2 in my denominator over here. But I can't just add something to the bottom of a fraction. So I'm actually multiplying the top and the bottom by x plus 2. So now my new common denominator is going to be x plus 2, x minus 2. And then I'm going to make sure that I distribute the x to each of these terms. So I need to distribute to the x and to the 2. When I do that, x times x is x squared. X times 2 is 2x. And then I also have a negative 8, so I have minus 8. So my next step is to see if the numerator will factor. Sometimes it will, sometimes it won't. In this case, it actually does factor, and this one factors into x plus 4 and x minus 2. So I've replaced the numerator with what it factors into, so this is no longer there. And now I look and see if anything can cancel. So I have an x minus 2 on the top and on the bottom, so those cancel out. So that means that my final answer is x plus 4 over x plus 2. And I still need to do my domain restrictions, so that's from either of these factors, if it was ever in the denominator. So x cannot be equal to negative 2 or positive 2. So here's another example. In this case, the denominators are already factored. There's nothing I can do to factor this one. There's nothing I can do to factor this one. This one is subtraction. So again, I think it's a good idea to make the subtraction addition and make this 4x negative. So now, to get my common denominator, I need this one right here, which is 3x minus 1, to have a 2x plus 5. So I'm going to multiply the top and the bottom by 2x plus 5. I also need to multiply this one. This one has the 2x plus 5, but it's missing the 3x minus 1. So I'm going to multiply top and bottom of this one by 3x minus 1. The reason why I went ahead and made this a negative 4x instead of minus 4x is because now when I distribute, I will remember to be distributing the negative and the 4x. So I'm going to multiply each of these by a negative 4x, and I'm going to multiply each of these by a positive 6x. When I do that, I get 12x squared plus 30x. That's when I distributed the 6x. Now I distribute the negative 4x and I get negative 12x squared. Negative times a negative is a positive, so plus 4x over my common denominator, which is now going to be 2x plus 5 times 3x minus 1. I now have one of each of them. When I do, sorry, this should be squared. When I do 12x squared minus 12x squared, well, that's 0. So I have 30x plus 4x, so that's going to be a total of 34x over 2x plus 5 times 3x minus 1. And for my domain restrictions, x cannot be equal to negative 5 over 2 or positive 1 over 3. So here's my final answer, and here are my domain restrictions. Here's an example where I don't have a denominator here, so this is really just over 1. So my common denominator is going to be 3x minus 5. This one doesn't have that, so I still need to multiply top and bottom by 3x minus 5. And then I need to distribute the x squared to each of these two terms. So my common denominator is going to be over 3x minus 5. So 3x times x squared is 3x to the third. I have x squared times negative 5 is negative 5x squared. And then I have a positive 2x. So my next step is to factor anything that I can factor. So I can factor out an x. I have x and then 3x squared minus 5x plus 2. That was my GCF. This is over 3x minus 5. And now I have a quadratic trinomial, so I can see if that factors into a product of binomials. In this case, it does factor, so this factors into 3x minus 2 and x minus 1. If I were to expand just this part out, then I should get what I have in parentheses here. So 3x times x is 3x squared. I have a negative 3x minus 2x, which is negative 5x, and negative 2 times negative 1 is a positive 2, over 3x minus 5. So here's an example where I've factored everything and nothing cancels out. That's fine. I'm just going to leave it completely factored as my final answer, and I'm going to move on to my domain restrictions. In this case, it cannot be positive 5 over 3. So this entire part would be my final answer. You still need to factor it out to see if anything cancels. If it doesn't, that's fine. We want our answer to be in factored form. Here's one that looks difficult because we have this crazy fraction, but this is really a fraction divided by a fraction. And we never write a fraction divided by a fraction. Instead, we multiply it by the reciprocal. So I leave the top part, the 4 over x plus 2 alone. So this entire thing is 4 over x plus 2 times the reciprocal of this is 3 over x plus 2. And then this is going to be minus 3 over x plus 2. So I'm just going to make it addition now and make it negative. So this is going to be plus negative 3 over x plus 2. Now this one, because it's multiplication, I have x plus 2 twice. This one I only have it once. So I still need a common denominator, which will be x plus 2, x plus 2. So I'm going to multiply top and bottom of this one by x plus 2. So now, multiply these two together, and I get 12. I distribute my negative 3, so negative 3 times x is negative 3x. Negative 3 times 2 is negative 6 over my common denominator, which is x plus 2, x plus 2. Combine my like terms, so 12 minus 6 is positive 6, so I have negative 3x plus 6 over x plus 2, x plus 2. And now that I've combined all my like terms, my last step is to always factor the numerator now. So I'm going to factor out a negative 3. When I do that, I end up with x minus 2 over x plus 2, x plus 2. So we got really close to something canceling out, but again, here's a case where I've got everything completely factored. It just didn't work out that something canceled out, so I'm going to go on to my domain restriction. In this case, x cannot be equal to -2. I don't need to write it twice. If x cannot be equal to -2, then it still can't be equal to -2, so I'm just going to leave it written once. We'll go ahead and do one more example. So here's one where I think you should go ahead and try this on your own and then check and see if you got the right answer. So pause it now. Alright, so if you did it correctly, then you would see that I can't factor any of these, so I'm going to multiply the top and the bottom of this one by what it's missing. I already have the x plus 3, it still needs an x minus 2. This one has the x minus 2. It still needs the x plus 3. And then I need to multiply these two together. So I'm going to FOIL or do the distributive property twice. Here I'm just going to distribute the x to each of these terms. So when I do that, my numerator is going to be 2x squared. I get 3x minus 4x is negative x, and negative 2 times 3 is negative 6, so that was multiplying these two together. Now when I distribute the x, I get plus x squared plus 3x over my common denominator, which is x minus 2 times x plus 3. Combined all of my like terms, so I get this is equal to 3x squared plus 2x minus 6 over my common denominator of x minus 2 times x plus 3. Then your last step is to always factor the numerator if it can factor. So here's one, it looks like it should factor. You can try all of the possibilities, but this one just doesn't end up factoring. So I am going to leave it like this and go on to my domain restrictions. So x cannot be equal to positive 2 or negative 3. So hopefully now you should be able to add and subtract if you don't have a common denominator. So go ahead and do the problems on the right.